Good morning, everyone, or good afternoon. I'm Nishant Raj. I'm the data and AI strategy lead for Atlas Copco, IES division, where we focus on joining car body shells together through different joining technologies. And I look at overseeing the data and AI strategy across the division. So today's session, I'm going to focus on basically how can smart manufacturing vision be enabled through data. But before we start with that, I wanted this session to be a little bit more interactive. So in the description, you would have found a link to a mural page. And I'm going to share my screen to that page as well. And if all of you can click on that link and join me, we'll basically spend 5 minutes on this interactive session and before we jump into the presentation side of it. And the link is now in the comment section as well. Okay. Okay, I haven't seen anybody join in yet. Okay, in case we don't have anybody joining on this on the board yet, what I'll do is I'll jump to my slides and then we can jump back here to recap. Okay, so to start with, the vision of data-driven manufacturing is becoming real quite quickly. And one quote that I like to live by is, the future we see is the future you get. And this is very much true about what we are trying to achieve, because the limitations now within the industry is only limited by how far we are actually able to envisage in terms of the possibilities, because the technology is already there. So that brings us to the question of what and why. Sorry. That brings us to the question of what, why, and how. So why, firstly, why is this important? In the current trend, as you already see, and we've seen over the last year, that going back into factories or even just to maintain the production lines, it's becoming even more difficult than it previously has been. The skill gaps are huge. It's very difficult to find people to be able to do jobs anymore, and anybody of interest to actually do jobs such as manual handling or material handling, to just the same process day in and day out. And is bringing up the vision of the smart factory or a lights out factory, which would basically be a factory without anybody in there. That is enabled through not just the processes, but it's through the connectivity of all the processes within the factory, utilizing autonomous agents to do decision making. And again, without connectivity and data driving all of those things, it's not possible. And while we may think that this is a topic of future, or this is a smart factory of the future, it's actually happening now and has been for the last couple of years. So there's quite few factories in Europe and across the world that have already started to implement loads of these technologies. So From there, uh, the key thing that comes out is, how do you achieve this vision? Now we start off with this vision of, uh, with five different steps. So at the first step, you need to connect to the systems. If it's the preliminary requirement, and it's, again, this is not something new. It's been happening across different industries for a long amount of time. uh, the end goal is to apply AI enabled automation, but you have to take it through the step by step process. So you need to connect, you need to collect the data, you need to visualize the data, try to understand what is the data telling you, uh, drive insights, and then you get to the stage of intelligent production. And as you see the value proposition, uh, connect, collect, and visualize allows you to be able to uh, get the value uh, to a certain extent, and this is what we've all known. But the exponential value starts to come in beyond that step, and that's where it becomes difficult today, right? Because we're not experienced with these things. So the value proposition is not just restricted to building stuff for the end customer. It also comes back to your own internal processes, and there is a flow. So starting on from for internal value creation, you need to have data and connectivity across all of these layers that you see here. So it goes from starting from initial inquiry to sales to product management to R&D, product creation, entire production process, logistics, the entire internal processes and value chain that has. And that connectivity across and the data flow with the product across this stage is really important to be able to drive that internal value. And this is also very commonly missed because we focus a lot on external value creation and actually not a lot on internal value creation, because externally we can see a monetization potential quite quickly. Internally, it still is quite big potential, because you look at the time savings and productivity improvements and just the impact that you can make on your products, and then vice versa to your customers, is huge. So going from internal value, you obviously have to speak about customer value. And the customer value is, it's not changed at all. So it's still the same topics that we were uh, discussing previously, which is productivity, quality, efficiency, and uptime. So those have remained absolutely same. The end manufacturer still expects those same things. How we achieve that and what is possible, that's changed dramatically, because it's not just assisting your customer at a stage when they are already in production, but you need to go through the entire journey and help and add value to each part of the journey. So it talk about configuration stage. So even when they're thinking about combining, they want to utilize this process. And could you create digital twins for that? Could you make them come to a decision quickly? Could you make them choose a brand quicker? And have them all that information available before any physical systems are even put in place. At an operation stage is something that we know that that's where most of the customer interaction happens today. So there we have the data collection, you have systems, reliability of systems ongoing, you have the productivity outputs being shared with you through dashboards. And again, it's all that data that already sits there, and in most places are already in at these companies and manufacturing units in their local server. But who utilizes them, how it's getting utilized, is not necessarily a very standard process. And again, the data means different thing to different people. So a person working on the shop floor would have a different insight linked to his or her part in that process compared to somebody who's in management looking at the productivity of a plant. So it's important that the data proposition is used correctly and used in conjunction with who the end user is going to be. uh, at the maintenance stage of the customer journey, a lot of customers that we've seen within our industry is the maintenance is driven by schedules. And while that used to be useful previously, it's not necessarily value adding anymore, especially when you have such quite a big restriction in the amount of resources that you have and people and skill sets. So it's important that we optimize this and we do not have people doing a job just for this, just because there's no other way to do it. The thing with maintenance, things like predictive maintenance can actually reduce the amount of manual effort that is required immensely, because instead of going and doing maintenance on all systems just because they have hit a timeline, instead of actually knowing that they need to be maintained, and that process again is key and adding value. Now, one thing to add in here is ac- across any major OEMs, you would see that the OEM is one large company building one or different types of products, but then they have a host of suppliers all supplying their own technology into that OEM to be able to actually manufacture that product. So to expect that a single layer of predictive maintenance can be done across all is not necessarily true in my experience. You need to bring in the domain expertise of individual suppliers onto that data to be able to accurately be able to forecast and be able to drive more value from data than individually the OEMs would. So it's also changing how industry has worked previously, where it's previously been buyer-seller vendor relationship. Now it's going to be a more collaborative approach. And that collaborative approach is going to be a key to be able to drive any of this. Then going on to optimization. So, because we have the opportunity for connectivity across the production lines and the data flowing through those processes, there is high level optimization that can be done automatically and could be done as recommendations back to the customers, because now it's not just, hey, you can do these things on your line, but actually, hey, you've got these three other plants in these three other parts of the country or in different countries, and these are running with similar setup but in a different rate. So actually, if you make the same changes, you can achieve the similar efficiency and uptime and productivity across them. So it's very important that the customer is taken through this entire journey. So moving on from there, what I'm going to jump into now is a little bit more exciting stuff, which is I'm going to talk you through about life cycle or from an idea stage of a car to its production stage and how the data flows through that process. So let me just quickly move the screen. Give me one second. Okay. So with smart connected assembly, we are now, that's one of the visions that Atlas Copco is driving. And as I talked about earlier, the opportunities are still same. It's still about product mix, system complexity, human factors, sustainability. Now, the challenge of manufacturing have been these things previously. But the approach of solving them and with the technology that's available today is the key for us. So With smart connected assembly, there's 6 pillars of value, right? That can be addressed. So increasing the uptime, reducing the defects, um, new product introduction, improved productivity, human interaction, and reduction in energy use. So these are few of the key things that are really important as a core value that us at Atlas Copco we are trying to address, and this is what how we want to drive more value for our customers. Uh, so within the journey of uh, a car, you basically go through different stages, and that includes, from the prototype stage to the production stage, to finally, getting it released to the customers. And there is, for across all of that, this process is being done, there's data getting generated. It's important to be able to collect that data, understand the data, and be able to share that data across, if this work is being done in one part of the country, across multiple of those customers. So, today we are, you start from this journey of this concept of the car, and you go in, and the car is now currently in the prototype stage. So at the prototype stage, there are different processes that would happen. So you would basically, trying to again address the same pillar values. You start off with your tools. You take your prototype signing tools. You try out different processes, and once you have done that, you've set parameters. That data from the prototype stage is then flown through in terms of this central intelligence, and that then starts to drive that intelligence being shared across globally. Now that intelligence you would basically see is now moved. Now we're looking at a production level for an automotive manufacturing. So the first stage of the process is body in white manufacturing, where car body parts get joined together. There we have, this is a self-piercing riveting system, which would, you'll see the car body coming in, the tool going in and going, and then basically joining these dissimilar metals together. Once this is done, you would see, again, you're still trying to address the same quality values, increase uptime, reductions, productivity. At the end of that process, that entire, again, the data from that machine is then again shared across. The car would further move on to the next process where the sealing application is getting done. And again, as I say, the same theme of applying increased uptime, reduction defects across the systems, that is common. And again, when the process is done, those process parameters, the results, all of that is again shared across. The car then moves on to getting parts of its body bolted in together. And again, the data from these processes being shared. From there, it moves on to the assembly line, right? So within the assembly line, again, you have these manual stations where different activities need to be performed on the car. In here, the focus, as I said, has all been same. All the data that has taken place across in the previous processes is shared through as with the car as it moves forward. So there are points that have been identified in terms of what works needs to be done. That establishing into what applications need to be done. We have systems like virtual controllers, so you can have multiple setups being part of the same system. You have flexibility with virtual stations. So the components which are customer critical, systems which are quality critical, and systems which are safety critical. So again, all of these processes are applied. The tasks are done. There's wireless tethering. So actually, the tools, if you say these wireless tools, cannot if it's programmed for one specific part of the car for one job, if you walk out of the session, walk out of the zone, it would not work. So it stops you from making, doing wrong joints on the car, which can be safety critical. And again, that is all powered through connectivity and data. So, once the process is done, again, through the interaction data, we can send messages, and the person on the line can look at, okay, this is the inspection task I need to do. How do I, go about doing it? Gets instructions for that. And again, all of those things, all the processes that have happened, all the data that's been generated through this process is then shared. So it's all come through. We have gone through different processes. We are turning data into insight. And imagine this, right? So this we have showed and captured for the data happening just through one car, right? And the traceability, not just through these tools, but through even manual wrench tools that's been generated. And all that data is then utilized to actually drive insights across the shop floor. And that's what is essential, that there is this connectivity, there is that data sharing, there is this seamless line through that entire process of data connectivity and intelligence. And what you're able to then do with that is actually connect that data, start analyzing, build recommendation implementation, and help your customers improve. So you have things that. So you have things like notifications apps. And here, we can actually utilize data to give the notification back to the customers saying, hey, this needs attention, or here's some changes that we've identified in the line. You have things like maintenance manager. So again, it gives you an overview of which systems are, running, when they're due for maintenance, have they been calibrated, what's their, how much wear does exist on their systems today. Look at production optimization. So things like, how's the shift ending? Is one shift better than the other shift? How can those problems be solved? So through this connectivity layer, we are able to drive customers to be able to, understand the data, utilize that data. And all of that, as I said, it is driving the optimized process, maintenance process, but it still is achieving the same values, right? So it's all of that done is still to achieve the same values of increased uptime, reduction in defects, new product introduction, improved quality, human interaction, and reduction in energy use. So at the end of that, we've gone through this entire process of conception of the car body to this multiple process, the data being shared across them. And this is where, in the end, you have got your physical cars, from the customers going out, and digital twin of that, created through that data that would exist across. And this is something that you utilize further and go through this iterative process with new design to improve designs, to improve safety, and so on. So that's was basically the slide deck that I wanted to go through. If you are still here, we can do a very quick jump on the mural board. If not, I'm happy to take any questions as well. Okay, I can't see any questions coming through just about yet. So what I'll do is, we've got one person here, so actually we can do a very quick sort of session on, so what I've tried to touch upon, and I can basically give you some instance about, what, why, and how. So I've talked about what, what, why, and how we're trying to do this. Now, what does it mean for you, right? So what does smart factory or data-driven manufacturing does it mean to you? Yeah. So the value from the products can be measured. Again, it's you're basically seeing what are the inefficiencies in the processes today, right? And that's why you start to sort of look at what the opportunity lies. And through the connected networks, you can actually understand and visualize what the opportunity with data lies and what improvements can happen. And then taking those actions can then have its own ROI as well. So, going back to just reiterating on the topic, and since I don't have any direct questions, I can answer some of my own. Is the key thing is, where do you start? And the start point with any of this starts with the smallest process. Try to entire value chain, from the concept to the creation, and what data flows exist. Can you extract the data? Do you need to partner up with of the data to understand what it means? And how can all of that actually still continue to drive your key goals in production, really? And one last thing that I also like to just add in is one of the key elements with any of this is you need to apply an agile process to achieve this. So traditional processes are very difficult to use for smart factory implementations. Okay, I've got a question. How are you matching the manufacturing capability with the level of intelligence? So this is, again, this doesn't have to be done on your own. There are more than enough partners available, both from university to funds available from the government to other people who have gone through a similar journey. Technology has become very accessible. So even traditional and legacy equipment can actually have data collection sources, including, you can add in new sensors to them. There are connectivities that can be added to that. So this change that we are seeing is not just with new equipment, but also with legacy equipment. And I think that's all the time we have. So thank you, everybody. Thanks for joining in.